we are adding subtracting rational expressions, which means we need a common denominator, right? That's the big difference here. Need a common denominator. So in order to decide what the common denominator is, we wanted to look at this in its factored version. So if we wrote this as x over x minus 9, nothing changes there, minus, I'm hopeful that you can see the x plus 144 here stays alone, but we really want to factor this denominator. And I hope you can see we need two numbers that multiply to negative 72 and two numbers that add to negative 1. So that would be a negative 9 and positive 8. That makes that happen. So this factors into x minus 9 and x plus 8. Therefore, we can see the first fraction has the x minus 9, but it's missing the x plus 8 factor, which means we've got to multiply top and bottom by an x plus 8 here. Now that we have the common denominator, you could write this whole thing over the x plus 8, x minus 9, excuse me. And then we really want to combine the numerators, right? We can simply just subtract across. Be very careful. There is a subtraction sign, so we're going to have to distribute the negative. We're also going to have to distribute that x through the first numerator. So x squared plus 8x minus x minus 144. So when we combine our like terms in the middle, we get x squared plus 7x minus 144 all over. We can just keep that denominator factored. And I think what we're looking for here is, can this thing factor in the numerator anymore? Do we have two numbers that multiply to negative 144 and add to positive 7? I think you'd say 16 and negative 9 would do that, which means this would factor into x plus 16, x minus 9, still all over the x plus 8, x minus 9, and now your x minus 9's cancel, and you're left with x plus 16 over x plus 8. Do not be tempted to reduce the 16 and the 8 or cancel the x's. They are connected by addition. We have to stop here. Okay, similarly, the next one, we need a common denominator. So let's go ahead and factor that first denominator. I hope you can see this would be an x plus 4, x minus 3 here. So that means that we're missing, we've got the x minus 3 in the second fraction, but we're missing the x plus 4. So we'll have to multiply top and bottom by x plus 4. So now we have a common denominator, x plus 4 times x minus 3. We'll just simply add the numerators as we see them. So be very careful to distribute the positive 6 through here. So this is 10x plus 1 plus 6x plus 24. Combining our like terms, we have 16x plus 25 is equal to x plus 4, x minus 3. And I think that looks good. There's nothing to factor out of the numerator. Nothing cancels with the denominator. So we will stop here. With this last one, number 11 on this line, I hope you can see that these are opposites as far as the denominators go. So there's no need to get the full on common denominator. We could simply rather just say, if we could factor out a negative 1 from one of them, that would change the signs and make them the same. So really what we do is we just switch the sign in the middle. So this stays 7x minus 5 over x minus 4. We can move that negative in the denominator up to the middle of the fraction, and then we've got minus 3x plus 11 all over x minus 4, right? So we just basically have to switch the signs, which switches that sign in the middle. So we have a common denominator. This whole thing is over x minus 4, but again, be careful to distribute that negative in the middle when you go to combine the numerators. So this would be 7x minus 5 minus 3x minus 11. When we combine like terms, this becomes 4x minus 16 all over x minus 4. Would you look at this? We can factor out a 4 in that numerator, leaving us with an x minus 4 all over the x minus 4, and now those factors cancel. So this whole thing simplifies to 4. With 12 and 13, as we keep moving down this list, this is that fraction within a fraction. If we can multiply the top and bottom by the LCD of all the mini fractions. So this is like over 1 here. This one's over 1. So the LCD of all the mini fractions in number 12 would be x squared. So if we can multiply the top by x squared and the bottom by x squared, we're not changing the problem. And then we can clear all of those little mini fractions. So let's do the numerator first. This becomes x squared times 1, so just x squared. In the middle up here, one of your x's cancels, so you're left with a 15x. And then in your third part here, both the x squareds cancel and you're left with plus 56. By similar measure down in the denominator, we end up with an x squared plus 7x. At this point, we would look to, very similar to the previous problems, simplify. Can we factor anything? So over here, can I find two numbers that multiply to 56 and add to 15? You bet we can, 7 and 8. So we'd have an x plus 7 times an x plus 8 all over, that denominator, I can factor out a common x and be left with x plus 7. So here our x plus 7's drop, and we're left with x plus 8 over x. Remember that because of that plus sign in the numerator, we cannot cancel the x's, so we would be done here. With number 13 here, our LCD for all of the little mini denominators, we need x minus 1 and an x. Again, we need an x minus 1 and an x to clear these. So we're going to need both pieces. So that LCD would be an x times x minus 1 here. So we'll multiply the top times x minus 1. And we'll also multiply the bottom times x minus 1 to clear all those mini denominators. So let's do the numerator first. I hope you can see that the x minus 1 would cancel, and so that would leave us with a 6x minus, when we go to the second fraction up on top, the x's would cancel, so it would leave us with a minus 2 times x minus 1. All over, distributing through to the denominator, the x minus 1's would cancel, leaving us with 5x. And again, the second fraction here, the x's would cancel, leaving us with a plus x minus 1. 1 times x minus 1, but we don't really need that. So let's start cleaning this up, distributing through the negative 2 in the numerator. We end up with 6x minus 2x plus 2, all over, combining like terms, we've got a 6x minus 1. If we combine like terms, we end up with 4x plus 2, all over 6x minus 1. And while you could take out a 2 in the numerator, I'm not sure that that helps us at all. It's not going to make any of the factors cancel. So either one of these would be okay answers here. To solve rational equations, this LCD notation still plays in here. We want to multiply the entire equation through by the x plus 7 to clear all the fractions. So in that first fraction, the x plus 7's would drop. We'd be left with just 1 minus. We still have to multiply the 3, even though it's not a fraction, by the x plus 7. And over here, the x plus 7's would drop, leaving us with the minus 5. Careful with the negative sign there not to miss it. And so we end up solving a relatively basic equation here. Distributing through the negative 3, we get 1 minus 3x minus 21 equals negative 5. Combining the 1 and negative 21, we end up with a negative 3x minus 20 equals negative 5. If we add the 20 over, we get negative 3x is equal to positive 15. Dividing by negative 3, we end up with x is equal to negative 5. Making sure that we check for extraneous. I'm just going to write this down. Check for extraneous solutions, because that could happen here. Right? We can't have denominators equal to 0. So if you look back at your original problem, notice we wouldn't be able to plug in a negative 7 for x, because that would give us a 0 here. So that would be bad, but we don't have a negative 7, we got a negative 5. So I think this one would check out. In number 15 in the middle, in order to figure out the LCD, hopefully you can see this is a difference of perfect squares, x minus 2, x plus 2. So then the LCD itself is the x minus 2, x plus 2, and here we've got both of them. Right, so we'll multiply the whole equation through by x minus 2 times x plus 2. So in the first fraction, the x minus 2 cancels, leaving us with a 7 times x plus 2, plus In the second fraction, the x plus 2 cancels, leaving us with a 3 times x minus 2. And then in the second, on the right-hand side of the equation, the whole thing cancels, leaving us with a negative 12. Again, careful not to miss that negative sign. So if we distribute and clean this up, we end up with 7x plus 14 plus 3x minus 6 equals negative 12. Combining like terms, we end up with 10x plus 8 equals negative 12. Subtracting 8 over, 10x is equal to negative 20. Dividing by 10, we get x is equal to negative 2. But you can see, hopefully, when you go to plug this back in, that becomes a problem. So our one solution that we came up with does not work. It would make that middle denominator 0. So that's enough to say there's no solution. In number 16, we would want to multiply the entire equation through. We're going to need an x to cancel that first denominator and an x plus 3 to cancel the next ones. So here those x's would cancel, leaving us with 2 times x plus 3. In the second fraction, the x plus 3's would cancel, leaving us with a minus 3x. And again, in that right-hand side of the equation, the x plus 3's cancel, leaving us with an x squared. So if we clean this up, we get 2x plus 6 when we distribute, minus 3x equals x squared. I'm hoping you're seeing what I'm seeing. And that is that we are going to end up with an x squared, x in number terms. We've got to get this thing equal to 0. I'm going to move everything to the right-hand side because I want to keep that positive x squared. So 2x minus 3x is a negative x plus 6 equals x squared. Getting those things on the other side. So let's add over the x and subtract the 6. Add the x, subtract the 6. So 0 is equal to x squared plus x minus 6. This guy factors into what multiplies a negative 6 and adds to positive 1. We'd end up with an x plus 3 and an x minus 2. So x plus 3 equals 0, or x minus 2 equals 0. So x equals negative 3, or x equals 2. But again, checking our solutions, I'm hopeful that you can see a negative 3 plus 3, that would be bad up here. So this guy is going to go away and be extraneous, and we're only going to be left with the x plus 2. For number 17, our last one on this page, if we're solving for a, we've got to get a out of the denominator. In fact, it'd be great if we could clear all of the fractions. So let's multiply by the LCD of AB, right? A to clear the first fraction, B to clear the second one. So if we multiply by AB, the A cancels in the first fraction, so we're left with a 6BC, plus the B cancels with the second fraction, so plus A is equal to, don't forget to multiply that 2 by AB, so 2AB. Since we are solving for A, we need to get all the A's on one side. So I'm going to subtract the A over to the other side. So this is 6BC equals 2AB minus A. We have two terms on that right-hand side. Both of those terms have an A. So let's go ahead and factor out the common A. We're left with a 2B minus 1. We still have this 6BC on the left-hand side. To get A alone, we can now just divide off the 2B minus 1. And so A is equal to 6BC over 2B minus 1.